Last part of section 1.3 is trig limits. There are two special trig limits you need to memorize, and here they are. The derivation or the proofs of these limits is a little beyond the scope of our class, but it is really interesting. So if you're interested, come in and talk to me, and we can walk through them. In our first example, as always, we're going to start off with kind of an easier example. Here I have the limit as x approaches 0 of sine of 5x over 5x. All right, and this really fits the form of sine of x over x. As long as the argument of the sine is the same as your denominator, that limit is equal to 1. Next example, I have limit as x approaches 0 of the sine of 3x over x. Notice that the argument of sine is 3x and the denominator is just x. So in order to get this into a form that looks like my special trig limit, where the argument of the sine and the denominator are the same, I need this to be a 3x. In order to do that and not change the value of the function, if I make this 3x down there, I have to multiply by a 3 in the numerator of that function. So what I have now is the argument of the sine is exactly the same as the denominator. So this function here, sine of 3x over 3x, we know from our special trig function up here that this limit is 1. So we're just left with 3 times 1, and our final answer is 3. Here I start off with the limit as theta approaches 0 of the secant of theta minus 1 over theta times secant theta. All right, so these get a little bit more complicated. Notice that our special trig limits, I'm going to look up here again, I have a special trig limit for the sine of x over x, and I have a special trig limit for 1 minus cosine of x over x. So notice that both my special trig limits are either in terms of sine or cosine. So that gives me a clue as to how to approach these. Most of the time, the way to go is to try to turn these into sine and cosine, and then go from there. So I'm going to do that. I'm going to use the definition of secant of theta. Secant of theta is 1 over cosine. So I'm going to substitute 1 over cosine in for secant here and secant here. And then I see that I have these complex fractions. I have a complex fraction in the numerator and a fraction in the denominator. So I'm going to multiply through by the LCD. And what I see when I do that is when I distribute this cosine theta to this term in the numerator, it cancels out the cosine. So I have 1. When I distribute it to this minus 1, I get minus cosine, so that's where the 1 minus cosine theta came in the numerator. In the denominator, this is a product here. When I multiply the cosine theta times 1 over cosine theta, those cosines cancel out, and I'm just left with theta. And that looks just like the special trig limit that I memorized up here. Cosine of x, x approaches 0. I'm sorry, it was cosine of 1 minus cosine of x, and x approaches 0. Here it's 1 minus cosine theta over theta, and theta is approaching 0. So I just need to make sure that the argument of the cosine, the denominator, and the value that's approaching 0 are all identical, and that limit equals 0. All right. These ones are definitely more complicated. With trig limits, you try to make it look like some version of one of the two special trig limits that you have memorized. Right? Okay, yeah, if these still seem easy, you can feel a little smart now. These ones are a little trickier.